Hi, my name is Beth from My Tutoring Bee, and in today's video we are talking about solving systems of equations using the substitution method. I've got a couple examples for us, so let's go ahead and get started. Here we have our two equations, that is our system of equations. Now the solution for a system of equations is the x and y values that satisfy both of these equations. A lot of times it's one single point. Sometimes it can be no point, so there is no solution to a system of equations, and sometimes it can be infinitely many points. I do have a couple of videos coming up about each of those types of systems, but let's take a look at this system and see what we get. So we are being asked to specifically solve using substitution. So when we are using substitution, keep in mind that our y values and our x values should be the same. So if the y equals 2 over 3x plus 9 in this first equation, then it also equals 2 over 3x plus 9 in this second equation. So that's where we get the substitution name from. So what we're going to do, since this first equation is already set up for us and solved for y, that makes it really easy for us to take this side of the equation, substitute it into the second equation, and then we can solve for x. We can't solve an equation when there are two different variables. So right now, neither of these equations are solvable by themselves. But watch what happens when we substitute in this portion of the first equation into the second equation. So I'm going to rewrite this as 4x plus 3, and then instead of y, in parentheses, I'm going to have 2/3 x plus 9 equals 15. So I've just taken this y out and substituted in that portion of the first equation that I was told that y equals. Now we have an equation with only x. So that's going to allow us to solve for x, and we are going to figure out what our x portion of this solution is. Remember that a solution for a system of equations should be a coordinate point. So we're going to find an x value and a y value. All right, let's go ahead and simplify and solve this. So for x, we're going to go ahead and distribute this 3. When we multiply 3 times 2 over 3x, the 3's are actually going to cancel out, leaving us with just a positive 2x. And then 3 times 9 gives us 27, and that equals 15. Okay, let's go ahead and combine our like terms. We've got 6x plus 27 equals 15. Subtract 27 from both sides. So we've got 6x equals, let's see, 27 minus 15 would give me 12, and that should give us a negative 12 since the 27 is negative. And then divide by 6, x equals negative 2. So we found the first part of our solution, which is negative 2 for the x value. Now what we can do is take that x solution that we found and substitute it into either of these equations. It does not matter which equation you choose. Both of them will give you the same answer because, again, this x value should be the same value in both of these equations. So I'm going to go ahead, and since I don't want to have to deal with this fraction in the first equation if I don't have to, I'm going to go ahead and substitute it into the second equation. So we've got 4 times negative 2 plus 3y equals 15. So again, what I've done here is I've removed that x, and now all I have is a y in this equation, which means I can solve for it. So 4 times negative 2 is negative 8 plus 3y equals 15. And then we're going to add 8 to both sides. We get 3y equals 23. And then we're going to divide by 3, and y, since this doesn't go in evenly, I'm going to leave it as an improper fraction. We could turn it into a mixed number if you prefer that, but that is the y portion of our solution is 23 over 3. And this is a great example of where substitution is really helpful in finding the solution to a system. If we were to graphed both of these equations, we probably could have graphed each line with no problem, but because this y portion of the solution isn't an integer, it might be really hard to tell exactly where those two lines line up on a graph. So substitution is a great way to solve a system when the solution isn't perfect integers. Let's take a look at another system of equations where we're being asked to solve using substitution. So looking at these two equations, neither of them are solved for x or y. And that's what we want for substitution, because we want to be able to know what either x or y equals for one equation so that we know what to substitute into the second equation. So we're going to have to manipulate one of these equations and get it down to either x equals something or y equals something. So since we have that freedom, we can take a look at our equations and decide what's going to be the easiest for us. If we can make our lives a little bit easier, let's go ahead and do that. So it looks like on this second equation, I'm looking at this fraction and I want to get rid of that fraction if I can. If I don't have to deal with fractions, then let's do that. So I can get rid of this fraction by multiplying through this entire equation by 3, right? Because this 3 is going to cancel out with the 3 in the denominator here, leaving me with just x. And then 3 times 4y is 12y. And then 3 times 5 is 15. Okay, so now I know what I have to substitute into this other equation. So since x equals 12y plus 15 for this equation, then it will equal 12y plus 15 for this first equation. Let's go ahead and rewrite that with the substitution. So 2, and instead of x, I'm substituting in 12y plus 15 minus 8y equals 14. Okay, let's go ahead and simplify and solve for y. Now we have an equation with only y, no x's in this equation, so we can actually solve for y and get a value. So 2 times 12 is 24y, plus 2 times 15 is 30, minus 8y equals 14. Combine our like terms, so 24y minus 8y gives us 16y, plus 30 equals 14. We're going to subtract 30 from both sides. So we get 16y equals negative 16. Divide by 16, divide by 16. So y equals negative 1. So that is one part of our solution. Remember that a solution to a system is an x-y pair, coordinate pair. So we don't know what the x is yet, but for the y portion, it's going to be negative 1. But now that we have that, we can substitute that into either of these two equations for y. Again, I don't want to deal with that fraction right there, so I'm going to use this first equation. So we've got 2x minus 8 times negative 1 equals 14. So again, our goal here is to get rid of one of the variables so that we can solve for the other. 2x, let's see, negative 8 times negative 1 will give us 2x plus 8 equals 14. Subtract 8 from both sides. That gives us 2x equals 6. And then we're going to divide by 2, x equals 3. So that is the x portion of our solution. And of course, we can check our work by substituting in the x and y values for both of these equations, these original equations, and make sure that they do create true equations. So again, we have a true equation. So this is the solution for both of these equations, meaning that it is the solution for the system of equations. I hope that this video was helpful in learning how to solve systems of equations using the substitution method. I do have some other videos on how to solve systems using graphing and the elimination method. I also have a couple of videos when there is no solution and infinitely many solutions. So check out the links for those in the description below. I'm also offering one-on-one tutoring online. So if you're feeling like you need a little bit more support in math, then feel free to reach out to me. All of my links to reach out to me are in the description as well. Don't forget to like and subscribe. That does really help me to continue making these videos for you. And I'll see you next time.